I would like to familiarize you with the organization of the memory in the PLC. First of all, I would like to show you in table which I prepare in the Excel, which show how we transfer binary system to our decimal system. How it look like. So first thing, from the right to the left, here we have got the youngest, the lowest bit, and it is 2 to the power of 0, so it is 1. Here is 2 to the power of 1, it is 2, and so on. Here is an example of our memory bytes, M0.0, and so on. And here, for example, that this value has the value 1, here value 0. So here we have got 1 multiplied by 1 plus 0 multiplied by 2 plus 1 multiplied by 4, and so on. When we this everything calculate, we have got the value 133. We can do also the same using our calculator in the system. We have to change our view for the programmist, and in the programmist we can see our bytes. We can change it to, for example, the byte in order to better and easier view, and write exactly the same. We can click on these digits, and it is first, third, and last. With, of course, word, because when we make it on byte, last digit is for the sign, so we cannot make it. So for example, for word we can have obtained this value 133. And when we change for our organization block, how it look like in our PLC, we can see that the youngest bit is here, M0.0. Everything comes from the left to the right, so MB0, MB1, MB2, and MB3. MB, as we can see, it is 1 byte. 1 byte has 8 bits. Next we have got word, so word has 2 bytes, MB0 and MB1, which has, of course, 8 bits, so one word has 16 bits, and double word has 32 bits, 4 bytes, and 2 words. So it is a little bit complicated, but when we can see it on this visualization, I think that it's easier to understand. One important thing, Siemens makes something like this, as we can see here, that everything comes the numeration from the left to the right, so MB0, MB1, but look at the bits, so the youngest bit is on the right, MB0.0, and comes to the left. And of course in MW0 we can see that MB0, so our oldest byte, is our lower value, so we have to be careful about writing these values. In order to check this, what I have told you with using our Excel table, I can show you that in the PLC, in this watch and force table, when we create our watch table, we can put here something and check if our organization is exactly this what I told you 1 minute before. So MD20, please write exactly this what I write here. Here once again MD20, next MB20, MB20, next MB21, next MW20, and MW22. Additionally, I would like to write here 1 byte, M20.0, M20.2. This display format, first please change to dets, so decimal without sign. Next, binary. So choose for each representation, click binary representation, as I make it. Next, the last two bits must be bool because it is only true or false. When we have got this, please switch on monitor, and at start, if you have some values here, please write here 0 and click this icon. Yes, we have got this, modify this icon with the number 1 here, exactly. We should have everything in zeros, and next write the value 1, 2, 3, 4, 5, 6, 7, 8, 9. When you write it in the first value, in the decimal place, click once again this lightning icon, and you should have obtained something like this. And now you can once again see if our representation is correct according to our table in Excel. You can see that we have got here our oldest bits and the youngest. How we can transfer it to MB? You can see that MB20 is exactly this first thing, and MB21 is this second part to this part. Next is MW20, so it is exactly MB20 and MB21. You can see that MB20 is this first, and here we have got the second MB21. MW22, we can see that it is exactly this part. So you have to very carefully see this and understand why it is exactly in this way. And the last thing, we can also observe bool value of each bit. How we can make it? You can write M20.0 as we make it, and we can see that it is true, so there is 1. Where it is exactly this M20.0, we see that it is MB20.0 is this part, so in MD it is this one on this place. It is 0, position 0, position 1, position 2. If we write on position 3, it should be false, so you can add as many points as many you want. You can see that when we write M20.3, it is false, so it is exactly this third position which we have got here.